Alright, so here's our example. We have a given differential equation. So dy dx is equal to x minus y. Alright, so here's the way the question might be worded. Let y equals f of x be the particular solution to this differential equation with the initial conditions of 1, 3, f of 1 equals 3. So that means that our starting point is x equals 1, y equals 3. Use Euler's method starting at x equals 1 with three steps of equal size to approximate f of 1.6. So we want to go from the point 1, 3 to x equals 1.6 and some y value. And we're going to take 3 steps. So you can see that we go from 1 to 1.6. So in 3 steps, our step size each time is going to be 0.2. So let's look at how we would do this. So first we want to move and find the y value for x equals 1.2, our first step. So we're starting at 3, that's our original y value. Our step size, or our dx, is 0.2, a positive 0.2 because we're going from 1 to 1.2. And the slope at the point 1, 3 is given by this differential equation, x minus y. So it's 1 minus 3. Alright, so here's our original y value. Here's our dy. This is the slope at the point we know times the dx. And when we multiply this out and subtract, or we'll take 3 and add that negative number, we get 2.6. So our new point is 1.2, 2.6. So we repeat that process. So we have our x value is 1.2, our y value is 2.6. So to estimate f of 1.4, we start at 1.2, 2.6, and we do the same process. So our current y value is 2.6. X minus y is 1.2 minus 2.6, and our dx is 0.2. So we get 2.6 times negative 1.4 times 0.2. We do some arithmetic here and add the 2.6. We're subtracting now a smaller number, so well, a smaller number than we were here. So our dy is a little bit less than it was last time. So we have a new y value of 2.32. And that's our next point. 1.4, 2.32. Right, and we repeat that process again. So we've gotten to 1.2, 1.4. We want to go to 1.6. We're going to take one more step size of 0.2. So our dx is 0.2. Our y value, our current y value is 2.32. The x minus y tells us the slope there. So here's f prime, or dy dx, at this point. 1.4 minus 2.32. Do some arithmetic here, add 2.32, we get 2.136. So using Euler's method, given that differential equation, using 3 step sizes of 0.2, our estimate of f of 1.6 is 2.135. Alright, you can see little depiction of that as we start at our original point. We calculated the slope there, and we followed that straight line 0.2 units over, and we ended up here. Then we calculate a new slope, and we follow that straight line 0.2 units over, and we end up there. And then we calculate the slope there, and we follow that straight line 0.2 units over, and this is our final estimate of f of 1.6.